Time for our application. And that is when we see when in the world we might actually use some of this. So I will tell you that you use it in math, but really you use it in science, in the physical properties of science, in geology and geography, when you're talking about earthquakes and Richter scale. The magnitude of an earthquake is the log of the amplitude of a seismograph. You use it in chemistry, which we'll look at next week. You use it in physics when you're talking about the loudness of something in decibels. And there's actually an example worked out in your book on page 493 for loudness. I'm going to do the one not on loudness, but on earthquake intensity or magnitude of an earthquake. So let's look at applications and applications of a common log. And it really is cool because you will. When you're doing problems like this, you are functioning as a scientist, taking information, using math to then help you figure out what's happening in the science. So if you look on page 493, there is a problem. On 492, at the top of the page, there is a chart on Richter scale values and earthquake intensity. So if you look in your book right here, right there, okay? Right there. It says Richter scale value and intensity. Seismologists use the Richter scale to measure the strength or magnitude of earthquakes. The magnitude of an earthquake is determined using the logarithm of the amplitude of waves recorded by seismographs. And there are seismographs all over the world recording the Earth's activity underground all the time. The logarithmic scale used by Richter is based on the power of 10. So that's why we're looking at it today as an application of common logs. For example, a magnitude of 6.4 earthquake can be represented by 6.4 equals log of x, and x being the amplitude of the wave. We're not going to have to worry about measuring the amplitude of the wave, but we will use some values to determine how much energy is released. We have a formula. You don't have to memorize this. If I ask you to use it, I would always give it to you. We have a formula, and it says this, and again, it's in your book on page 493, but it says the amount of energy E in ergs that an earthquake releases is related to the Richter scale magnitude M by this equation. The log of E, so that is energy in ergs, equals 11.8 plus 1.5 times M. And this M is the magnitude of the earthquake. Our instructions say use this to determine how much energy was released by the Sumatran earthquake in 2004, which had a huge tsunami and an earthquake intensity of 9. So we'll say when M equals 9. So it's a plug and chug. That's the good news. And again, understood base 10. So I'm going to put 9 right here. 11.8 plus 1.5 times 9. So log of E equals, so now we go to the calculator, 11.8 plus 1.5 times 9, and we get 25.3. Right. Log of E equals 25.3. What do we need to do to solve this? I want to know what E is. So can't put it in my calculator as it is, but what can I do? You can rewrite it as an exponential. remembering the base, understood 10. So I'm going to say what? 10. And the log value in log form is the exponent value in exponent form. So we're just going to rewrite in exponential form. And that is helpful because when we're in base 10, we can use our calculators. So 10 to the 25.3 equals E. So this is going to tell us how much energy. Now this is a humongous number because 10 to the 6th is a million, 10 to the 9th is a billion, 10 to the 12th is a trillion. Y'all, this is 10 to the 25th. It is a ridiculously huge amount of power that was released with this earthquake. So on our calculator, we're just going to say 10 raised to the 25.3 and hit enter. Oh my goodness. And so this is what our calculator says. Can you see that? It looks like 1.9, but follow with your eyes all the way over and notice, what does it say right there? E25. So E25 means you're in scientific notation. So what that means, 1.99956, okay, we're going to round that to about 2. So we're going to say E is approximately 2, and then that E25 means 2 times 10 to the 25th power. So it is approximately 2 times 10 to the 25th. Monstrous. Huge, 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 unfathomably huge, powerful energy that was released in the earth. Okay, you're going to be a scientist yet. You're already a mathematician. Proud of you. So because this, we should probably write a sentence, shouldn't we? I should follow my own guidelines. The question is how much energy? So we would say let's say it this way. The 2004 Sumatran earthquake. I'm answering the question that was asked, so this is really important to write a sentence. Released 2 times 10 to the 25th ergs of energy. And that's just like mind-blowing that something is that powerful. Okay. All right. Fantastic. Hope you have a great afternoon or evening or wherever you are in your day watching this. I'm proud of you. Keep working. Keep thinking. Remember, Jesus loves you, and we're going to get through this.